All right, today is the 9th of April, 2026, doing problem of the day, and we're doing the second version of the same problem as yesterday. So it's my understanding, as in, I haven't fully read it yet, but my understanding is it's the exact same thing as yesterday. It's just, I assume, with higher constraints, like bigger problem sizes. Input data. You are given an integer array nums, 2D array, yes, with the LRKV, that's the same. Set the index to L while it's less than equal to R. Update this one so that you multiply and also mod it with a mod with a big number. And then, so you increment through. So same as yesterday, you increment through by size of K, starting at L, ending at R, and you do the multiplication, and you do that for every query. And now, yeah, so this is where, so yesterday it was a medium problem, and basically you could argue that it's actually, it was sort of not an easy problem, but the brute force solution worked because the constraints were small enough. It was like 10 to the 3 here and 10 to the 3 here. So you could get away with something. You could get away with literally processing each query individually, manually, brute force, with a brute force approach. And that worked. And I knew that this would probably be the problem for today because they normally when there's like a part 1 of a question, normally they do part 2 the next day, and I figured this would be the question. But so yesterday I kept going even after I'd solved the problem technically with the brute force approach. I tried to figure out what an efficient way would work. Right? I think I filmed that as well, but I never figured it out. So I ended the video early. So I'm not super optimistic about today. I probably will cheat. There's a couple of hints. I'll give myself like 10-20 minutes maybe. See how I go. But I'm maybe this is a bad attitude, but I don't back myself too much to figure this out by myself. Not this particular problem. I've seen problems that almost seem similar, but just not quite the same. Is the app open? No, it's not. So let me just make sure that the desktops are lined up like this. Okay. So this is 3655, like that. And so yeah, so you have the inputs, just to clarify, because I don't know if I explained it very well. The inputs are nums, which is an integer array. Oops. So that you're going to have an array filled with numbers. And from memory, the numbers range from 1 to like a billion or something. Yeah. So no negatives, which I don't think really means anything, but whatever. I guess because you have to mod, so it would always go positive anyway. So yeah, so you have some numbers, and then you have queries, which is a 2D array or 2D list. And the idea is, so you have an array that's full of lists. Whatever. And then each list in turn has 4 things in it, 4 numbers in it. The L value, the R value, the K value, and the V value. Right? So the idea is, I guess we can use one of the examples, roughly. I'll say 1, 4, 2, 3. So 1, 4, 2, and 3. What they're saying is, this is index 0, 1, 2, 3, 4, 5. They're saying start at index 1. So over here. Multiply it by the value 3. So this will be, from 3, this will multiply by 3, become 9. Increment by 2. 1, 2. So you're here now. Make sure you're not exceeded the right, and you haven't, and then multiply again. So multiply by 3, then increment by 2. 1, 2. Have you exceeded the right limit? Yes, you have. You're on 5 now, so don't that query is done, and then you can move on to the next query and go again. So left and right inclusive are the sort of index ranges, the index values that you can, the outer, what's the word? The bounds of the limit of the index values you can take for a particular query. K is how much you increase by from index to index, and V is the value you multiply by to each num, like array value. So this will become 9, this will become 18, because that's a 3. This becomes 9, this becomes 18, and so that would be the transformation after one query, and then you do that for all the queries. So that's the idea, and yeah, yes, like I said, yesterday's problem, you could just do it like that, exactly like that. You could just do it one query at a time, process each number that gets hit, each position that gets hit, you just multiply it, mod it, happy days. The question now becomes, okay, oh, and just to clarify, that was O of NQ, where N is the length of nums, and Q is the number of queries there are. It's the length of queries. Right, so that worked yesterday, but not today. So we have to basically figure out how can we, I think the big sort of issue is the N term in this. The issue is when we look at a particular query, we see the left, we see the right, and we see the K value, and we literally traverse through every, not every, but up until the right value. We have to touch every single value that's mentioned in this query. So if, for example, K is 1, right, this is probably the most extreme case, and L is 0 and R is, n minus 1, then you're literally going to have to multiply every single value. And if you do that Q number of times, where Q is the number of queries, then we get this extra factor. The question becomes, okay, if we take that case where K equals 1, we know that, okay, let's say L equals 0 and R is the end of the array. We know that this left value gets multiplied by V, we'll say 3, gets multiplied by 3. And then all these values continuously get multiplied by 3 until, in this case, the end, where I guess, in a sense, you should kind of divide by 3 at this point. Like you shouldn't, or maybe you multiply by a third, in the sense that the 3 should carry across, the multiplying by 3 should carry across, and then, by the time only after you get past the right value, should you kind of try and negate that multiply by 3. Now, it gets tough though when K is not 1. If K is 2, for example, then, every even index element gets hit. These guys get multiplied by 3, but these guys get multiplied by nothing, right? Like they're not affected by this query. So the question is, how can you efficiently, I guess, reflect that? What kind of structure would let you, see that? I remember I looked at the topics from yesterday, and it said divide and conquer was an option, and that's definitely not the brute force approach. I'm assuming it has something to do with divide and conquer. So I've already cheated a little bit, right? I have worked with a segment tree a couple of times. I think I talked about this yesterday as well. I might be recycling ideas. But this idea of like you have an array as like the root node, and then you sort of split it in half, roughly. Not exactly. And you sort of do that over and over again so that the leaf nodes are like the individual... Oh no. The leaf nodes are the individual elements of the array. And maybe from there you can sort of very quickly update the values. Oh no. I don't see how using it, because you have to multiply, because you have to adjust multiple values that aren't contiguous. I'm not sure if this is actually as helpful as I thought it might be. Like, okay, I multiply by 3 from index 0 to index n minus 1 with a k equals 2. So v equals 3, k equals 2, l equals 0, and r equals n minus 1. So looking at the whole array, we're going to multiply every even index by a factor of 3, is what this is saying. So how would I pass that information throughout the tree so that it's accurate and fast? Maybe I would realize that I know for sure that there's numbers on the left and numbers on the right, indices on the left and indices on the right that are affected, right? Because like those 3, so I would have to traverse down both, and then again, like in the left case, I'd have to traverse through both again because I'm here and here. On the right side though, I would only need to go through the left tree, sorry. I'd only have to go here because the 4 isn't affected. And then only 7 is affected, right? So we go down this way and we update. But I do still think in the worst case, you're still having to update all. Like, the fact is I feel like you shouldn't be updating all the elements at once. Is there an option on how big the increment value can be? 10 to the 5. Okay, so that's pretty arbitrary. Yeah, I don't think this is gonna cut it. Like, if k is equal to 2 in this particular situation, I'm still updating half the elements. It's still like a factor of n, basically. N elements that I have to update. So damn. I really don't have to use a hint, but I think I might have to. Divide and conquer. Not exactly binary. Normally they say segment tree if it is a segment tree. Like, normally that's a topic if you have to use one. So maybe that's not. Maybe this is not the right. Okay, I'm rejecting this idea because I don't think it pans out the way I was kind of hoping. What else could you divide and conquer if not the array itself? If you're not splitting the array up. Maybe you are splitting the array, but not in this sense. Split in half. What is it? Got so quiet. I don't know. Start index 0. How much time has it been? It's been about 10 minutes, 20 minutes. I don't think it's worth me just fluffing around, right? Alright, I'll cheat. Alright, here we go. Whoa, square root. For k less than or equal to b, what the heck is b? Where b is this? Oh, right, that's what it, yeah, sorry. For k less than or equal to b, group queries by KL mod k. What is L? Okay. Group the queries by how much you're incrementing by and the left. For each group, maintain a diff arrays of length ceil n over k to record multiplier updates. Then sweep each bucket to apply them to nums. Oh, of course. What? What did I just read? So for k less than or equal to the square root of n, k is referring to increment values, right? Or maybe it's not. Maybe k is not the same k, because maybe it's not that. And maybe L is referring to the L values though, like the left. Group query. No, but it must be the K. Why would they use K if it's not the same K? Like, they use L, like, you're grouping queries by those values, so it must be. Group queries by K L mod K. For each group, maintain a diff array of length n divided by K. I feel like this is kind of insane. Okay, so there's two. So for increments less than the square root of K, sorry, the square root of n. So for increments less than the square root of n, why square root of n? Maybe because if you're less than the square root of n, then like you're basically updating a lot of elements. Like the increment's small, so you're incrementing by like you're having to change a lot of elements. For each query, set idx equals to L. Okay, so my understanding is if k is big enough, do it brute force style, because you're updating few enough elements by jumping. Yes, if k, okay, yes. So hint two, what hint two is saying, and I think I kind of knew this, if k is big enough, and would, big enough meaning bigger than the square root of k, if k is big enough, then you don't update too many elements in the iteration, in the query. Like, because for example, let's say k is equal to the square root of n, right? Then you have an array like this of size n, and so on. If you start at index 0 and you have to increment by a value of square root of n, basically, then how many jumps do you have to do to get to the end of the array? Like, let's say L is equal to 0, R is equal to n minus 1. How many jumps, and k is equal to square root of n, how many jumps do you need to do to actually get to the end of the array? And it's like, well, it would be square root of n jumps, right? Because it's like, I do 1 jump, 2 jumps, 3 jumps, this many jumps, and I have traversed, in those number of jumps, I have traversed n, I've traversed the distance of n. Each jump has a size of square root of n, so therefore the number of jumps required was also square root of n. So basically, if k is big enough, that is to say, if k is greater than the square root of n, then the number of elements to modify, is less than the square root of n, not equal to, less than the square root of n, right? And therefore the time complexity will be q square root of n, I believe, under the condition that the query is in the increment value in the query array is big enough, is bigger than the square root of n. And that would be fine, I think. So if you have, because the square root of, is it fine? I mean, yeah, I think so. Square root of n is like 10 to the 5 to the power 10 to the 2.5. It's like 10 to the 5 times 10 to the power of 2.5, right? 31 million? Is that okay? Order of 10 to the 7, basically? Is that fine? I guess so. I mean, that's what it's saying, right? Like, this is basically just saying do brute force. I don't really understand. So, and now that, so that's like case 1. If k is big enough. But if k is small, so now like hint 2 is easier to understand. Hint 1 is a bit weird. If k is square root of n, group the queries by k and L mod k. Why are we modding by k? Because yeah, no, I think that makes sense. Because group the queries. The reason we mod by k, I can kind of understand why, I think. Because, like, let's say k is equal to 3, and you have one L value, which is, like, 1, and another L value, which is 4, so that when you mod it with 3, you get the same thing. Like, going from 1 to 4, a query that starts at 1 with an increment of value of 3 would have to hit 4. So, and then anything that starts at 4 will have to keep going. Like, the 1 to 4 and then keep going. It would be a very similar behavior as just like 4 without starting at 1. That didn't make any sense. Hang on. I think the reason why it says mod k in the hint is because if you imagine one query which has an L value of 1 and a k value of 3 versus another query which has an L value of 4 and also a k value of 3, Both of them will behave very similarly. It's just that they start at slightly different places. In fact, you could argue that the first query is like a sort of big brother of the second query. It's the exact same kind of jumps with one extra jump. So I'm imagining that's why they're getting you to group them together. They're very similar in that sense. Group queries by this tuple. For each group, maintain a difference array of n divided by k to record multiplier updates. Then sweep each bucket. What's a bucket? Is a bucket the array? Or is a bucket the element in the array? To record multiplier updates. So my understanding is you're going to have square root of okay. So in my mind, if k is like big, square root of n kind of thing, then there are square root of n many tuples that there could be, right? Because like you could have square root of n for the k value, and then like 1 up to, or 0 up to square root of n minus 1 is like the mod values after you mod L. So that's how many tuples you could have maybe. For each group, maintain for each group, maintain a difference array. So for each group of them, where the size sort of, it ranges between, I guess, square root of n up to n, because k ranges from 1 up to square root of n. To record multiplier updates, a diff array. So difference arrays, oh crap, what's the difference array? I've used difference arrays, now I've forgotten. Then sweep each bucket to apply them to nums. What? How much time has passed? 6:41. All right, I'll go for another 10 minutes, and then if I can't think of it, then I might cheat even more. I'll cheat the most. I'll read other people's stuff. For each group, maintain a diff array of length ceiling n over k to record multiplier updates. Then sweep each bucket. Okay, if I don't know what a difference array is, fine. But the fact that it's a size of n over k tells me that you're basically thinking about how many jumps are going to have to be used, right? Like how many jumps are going to exist. N over k, where k is the number of the size of a jump, tells you how many jumps there are. So each element in this array probably tells you oh, I kind of get it. Ish, but I don't know if it makes sense. I still don't really understand how this fixes the time complexity. I feel like I'm brute forcing still. But let me use an example. I think it'll be easier. Let's take this nums, but then only take the first query. Or maybe I'll make up a query as well. Okay. So we understand hint 2 pretty well. Let's just look at hint 1. So look at the example. 1423 as the query. And nums is equal to 23154. So in this case, the k, so n is equal to 1, 2, 3, 4, 5, right? The k value is 2, which is less than, k value is too small. We're going to have to do a few jumps, right? The L value is 1, the R value is 4. So this is the information about the query, and that's just the size. So what we're saying is, instead of like straight up updating, you know, straight away, what we can do is we can say, what can we say? Let's make an array of size n over k, ceiling, right? So this is my little bucket. N is 5, k is 2, so we get 3. And we know that this bucket will start, the start of this bucket refers to index 1. So obviously this is index 0, but I'm saying like it refers to index 1 in nums. So we know this guy, and in turn, sorry, this box here refers to index 3. And this index here refers to index 5, which doesn't exist, but whatever. So my understanding is you have to multiply by 3 and then divide by 3 here. That's why you're ceiling. Oh my god, it's starting to make sense. Oh my goodness. It's okay. So yesterday I talked about this idea of cumulative products and cumulative like divisors, whatever. You're literally doing that, but you're like grouping it in such a way that, remember, like the problem was I didn't have a contiguous array. We're basically forming this contiguous array for k that's small enough. Oh, it kind of works, but I don't. So here we're saying, you know, multiply by 3 here and keep that multiplied by 3 until we divide by 3, I think. And then if I was to do a second query, let's say we do another query, right? That's like, let's say we have a different, let's say we have a different k value right now. So remember that it's LRKV, right? Let's say instead of 2, we have an increment of 1 or increment of 3, and then 0 up to 0, 1, 2, 3, 4, 0 up to 4 with the value of 2, right? So if originally we had one sort of little bucket array thing, that's like instruction says to multiply by 3 and then accumulate and then divide by 3, then this guy would be another bucket because the increment value is different and the starting value is different. So we have to start at 0 and we have to increment by 3, 6. Hang on, size n divided by 3 floor gives you 2, doesn't it? That's the formula they gave, right? Yeah. I'm surprised there's no +1 or something. I would have thought you would want like an extra space, extra spot. Maybe I will just keep an extra spot. And the idea is, okay, you multiply by 2 and you keep multiplying by 2 until the value that no longer fits within their range. And so now if I do one more query that starts at, let's say, index 3 and has the same increment value as the original query, this one. And let's say it goes up to index 4. And we're multiplying by a value of 2. So this guy should use this bucket. We don't make a new bucket because it's the same increment value, and the 3 that we start at sort of is here. So the boxes we need to update are all within this bucket here. I don't know if that made any sense, but so what we're saying now is, okay, you multiply by 2, and you, who is outside my range, because my max index is 4 and you are 5, you should divide by 2, so you become divided by 6. And so by the end of it, we go through all our little buckets, and they have the instructions on what we should be multiplying a value by, or what we should be dividing a value by, you know? And we have to mod as well and everything. I think it makes sense. I don't really see how the time complexity, I kind of get it, because you're not applying, oh, I'm not sure. Are you really cutting down on work if you do it like this? Because I get that you're like, I get that you're not, I guess you're applying, you're kind of combining the results of the queries. Oh no, but yeah, because you're not, no, it doesn't make sense. Yeah, because you're not updating every single box with times 3 times 3 times 3. You're multiplying one end and saying to divide by 3 on the other side, past the, okay. I think I can execute this. It's not easy to even code, even if the idea is right. And I did have to cheat. But even if the idea is right, I'm not 100% sure I know what the best way to do. As in, okay, let's just try and follow the instructions, right? It makes sense because, like, I knew, like, the issue was there were gaps, right? The increment values were the gaps. But I couldn't, I don't know. I mean, this is a nice idea. It is quite cool. But it's still very messy in my mind. Anyway, let's see what structures we need. So I know that we need to keep all the buckets, and they are characterized by the tuple, so characterized by your k value and your starting position mod k value, right? So we'll probably have a hash table with keys that are these tuples, so we can find the buckets really easily. And the values will be integer arrays of size I think we can comfortably say n divided by k floor plus 1. I think plus 1 is fine. It's a bit of extra space, if anything else, if nothing else. And then we're going to go through a query. And yeah, if the k increment value is big enough, bigger than the square root, then we will just do a brute force approach. If it's too small, then we will have to check if the bucket exists, this particular thing exists. If it doesn't exist, we'll make one. And then for for the leftmost value, we'll add a multiplier. And on the right, and the first value after the range in the bucket, we'll put a divide sort of thing. So how do we signify if something's a multiplier or divide? Maybe each element, maybe instead of instead of an integer, we have a 2D kind of integer thing. I might be overcomplicating this now, but come on. Maybe instead of just integers, because I don't need to say 3, 2, 6. I have to say times 3, times 2, divide by 6. I have to instruct exactly how to modify these numbers, right? So maybe instead of numbers, just numbers, what if it's an array where each element is a multiply value and a divide value. And we, maybe it'll be, I want it to be modified, I want it to be mutable, so we'll actually put a list in a list. And this will be the structure of the values. It'll be, a 2D list, but each inner list is only 2 elements long. How much you should multiply by at this point, how much you should divide by. And that should keep track of all the information. So let's try it. So I'm going to need, I think the square root function is in the math thing, right? So, for, so L, R, K, and V inquiries, if K is less than the square root of N, I have not defined what N is the length of nums. If it's less than that, no, we'll do greater than or equal to. Wait, greater than? Greater than that. I think if you say, I'll experiment after actually. Let's just try to get this done. If it's greater than, then simply brute force. So we're going to say, for I in range L up to R plus 1 because it's exclusive, increment by K, nums at I equals nums at I, what the heck, nums at I multiplied by the V value, that's the value that we're multiplying by, and we mod it with the mod. Can I define mod in here, or is that, it'll be self.mod, won't it? Ugh, fine. Ten to the 9 plus 7, was it? It's always that, right? Well, not always, but more often than not, yeah. And then I'll say self.mod. Just, should avoid globals. Yeah, and that should be fine. Simply brute force. So that's that's the very literal way of handling a query, and that's fine for big enough K because you're not going to be updating that many elements. Else, if it's small, then I need to have my hash table. So my hash table is equal to this. If so if the K value, the increment value, and L mod the K value is in or not in the this guy HT, and HT at this tuple is equal to this we'll say 0, 0, just make the right number, right? 4 in the range of, so I'm choosing to go n divided by k plus 1. So with this floor function, it's division, it's integer division. Now just add 1 because I think it's nice to have the plus 1 there. So we make sure that the key exists, and then what do I do? Okay, I need to map. So in this case, obviously, this is index 0 in this array. This is index 0. However, this slot. However, it maps to index 1. So I have to be able to, based on so the way we decide that is we say, okay, I know the k value and I know the starting value is 1. Right? I know that, okay, this is what I know. The actual bucket index, if it's 0, I know it actually refers to the nums index. It actually refers to L mod k, right? Because L might not be like 1. L might be 3, like in this query, right? The third query we did. L referred to this value, but it's still the same bucket because it's the same jumps, right? So L mod k. So how do I say this? L, what am I doing? However many times it takes to get to L tells you how many times to get to the corresponding index of nums. Is that right? Or is it the other way around? Sorry. The number of, I said that the wrong way around. The number of small jumps it takes to get from here to here is the same as the number of big jumps it takes to get to L. So what am I trying to say? The relationship between the actual bucket index and the num index will be L minus L mod K, as its own little thing, whole thing divided by K will tell me the L value. And so in general, I minus I mod K divided by K should give me the I value. And we know that this guy, and I think in general, this will be an integer, because if we're getting an actual bucket index, like if we know L is an actual bucket, if we know that this L value is this L value with this K jump is, this is the appropriate bucket for it, then we know that there is an integer number of K-sized jumps to get from the very start up to this L index. In this case, in this case, there was a single two-sized jump, right? And in turn, there is one jump. There's a single two-sized jump in nums, index 1 to index 3. And then in here, there is one jump. I've overcomplicated it significantly, but I'm pretty sure this is the right formula. So bucket L is equal to L minus L mod K. Whoa, did not mean to do that. Whole thing divided by K. I should say K down here. So that's where like the multiply by 3 will go, the bucket L. That's where the multiply 3 will go. Now I have to figure out where the divide by 3 will go, and it will go bucket R. I think you can say, no, you can't. How do I determine where bucket R will go efficiently? So that's to say, because the query was 1 and then 4 with an increase, with a jump value of 2, right? A jump value of 2. We know, like, okay, we're going to hit 1, then we're going to hit 3. This bucket also has a 5, but we shouldn't update the 5 with a 3, right? We shouldn't multiply this value by 3. There's actually no 5 index, but anyway, just to make space. We shouldn't multiply this value by 3. Instead, we should say divide by 3. It says 6 now because of the other query. But we should divide by 3 so that we don't, we know not to multiply by 3. So like, we'll say multiply by 3 here, which tells us to multiply everything by 3 until we hit that divide by 3, in which case we say, okay, don't multiply this one by 3. Instead, we reduce the multiplier by 3 to bring it back to 1. So I need to figure out how to get this 5. And I think what I can do is, let me think about this. So we know that, the bucket looks something like 1, and then 3, and then we'll end with a 5, I think. So if a query, for example, looks like, let's say this one, L value equals 3, R value equals 4, jump value of 2, K value of 2. We know this is the bucket because it's characterized by that tuple. We know that this is the L value because we use this formula. L minus L L mod K, which is 1. Oh no, wait, I don't think it worked. No, it did work. L is 3, isn't it? L is 3. I said it wrong. This is a 3. 3 minus 3 mod 2, which is 1, divided by 2, which is index 1. Yeah, which is this one. Okay, I think it works, yeah. So we know that this is the starting point. How do we get the end point? Well, what happens if we plug this into... Obviously, this won't work because this isn't a valid bucket index, like actual nums index for this bucket. but 4 minus 4 mod 2, sure, divided by 2. So you get 0 here, you get 2 overall. It did work. I don't think it would always work though. Maybe you have to ceiling it as well or something. Because in my mind, it's like, look, I should be able to figure this out mathematically. Hang on, give me a second just to think. So L is like this, R is over here. We know that this refers to index 1. Oh wait, no, 135 is the index, sorry. We know it's 135. We need to find the first index that does not... We need to find the first index that's bigger, strictly bigger than the R value. That's what we're looking for, really. So, you know, obviously it's sorted. We could do binary search, but we also have the additional knowledge that this increases by 2. So, okay, here we go. We know the starting point and we know the ending point. So we know how much distance there is between. So R minus L tells us the distance. If we divide that by 2, that tells us how many jumps is required to traverse that distance. 2 being the jump size, right? So R minus L divided by K. And obviously this is a fraction because there's a distance of 1, but the jump size is 2. So half a jump basically gets us to 4, which isn't valid, obviously. So if we ceiling it, what happens? Well, it will tell us exactly the number of jumps needed as an integer. But I think there's an issue. So this tells us how many jumps will get us at least to 4. I think if we do floor and add 1, this will guarantee tell us how many jumps are required to get past the R index, which is what we want. So I think this is my formula. So bucket R will be R minus L divided by K, and then add 1 on the end. So this tells us which value should get the division value. So, all right, here we go. I believe that the bucket HT at K, L mod K, that's me accessing the bucket. Maybe I'll just say bucket equals that. And then bucket at bucket L at the M, the multiplier, versus the divide, which is 1. At the multiplier index, multiply position, should equal... Ooh, these should be 1s, not 0s, actually. Should equal this value multiplied by V modded with self.mod. And in turn, is it fair to say that this should equal this? Is that fair game? I'm scared about the mod. Should I just scrap the mod for now and then just like try and... Because it's Python, so I get away with it, I think. Okay. Now, obviously, hash tables traditionally shouldn't iterate through, but I think I will have to iterate through my dictionary. I think the best way for... I need to know the key and stuff, right? For jump value, L value, in the dictionary dot keys, bucket is equal to ht ht at the KL value, this tuple. So we're getting the bucket, and then we're basically saying for I in range bucket len is equal to length of bucket. So I in range bucket length. The num index is the conversion. Oh wait, yeah. Okay, I can do this. This is fine. This is easy. It's easier to go back the other way. So given a particular bucket index, because I have the bucket index, don't I? I is referring to the bucket index. Given a bucket index I, the corresponding num index, so if this is index 0, it refers to index 1, I have to so this tells me, if I'm at index 1, that tells me I did 1 jump. If I'm at index 2, that means I did 2 jumps. So it should just be L plus I times, so it's L times I plus L. Is it I plus 1 times L? L lots of I plus 1? I plus 1 lots of L? That doesn't sound right, does it? No, this can't be right. I need the jump value. It's, sorry, L plus K times I, sorry. How many jumps? This is how many jumps, basically. This is the size of each jump, and this is the offset, basically. Right? I think that's right. So if I test that here, 1 is the I, the jumps are size 2, and I add 1 because that's the offset. And then same thing here. Index is 2, I multiply by 2, I think it's right. So the nums index, the index that we're mapping to, is that. And so nums at nums index equals multiplied by bucket at I at 0 mod self.mod, and you also have to do a division thing as well. I probably don't need the mod if I'm dividing, but we'll say M for multiply and D for divide. Wow. Okay. I wonder if I'm like at all correct. Num index equals, yeah, it's like the mapping. Nums at nums index, go that, bang, and that. Okay, let us pray. So my answer is just nums at 0. I assume there's at least one. I assume there's at least one element, yeah. And then for v in nums from 1 onwards, we have to XOR it. So answer XOR equals v, and then we just return answer. So in theory, I think it makes sense. Did have to cheat, but I feel like it makes sense. I am very scared though, because like what I think it's doing versus, there you go. I did want to test that actually, because yeah, I am sort of the +1 from here. Like choosing to do +1, it does mean that some of the, so if nums index is greater than or equal to n, where n is the size of nums, then just continue, I think. Yeah, I was just thinking, instead of continue, we can say break, I think, because as soon as the nums index that we map surpasses the valid range, I'm pretty sure there's no point in continuing this in a for loop. Damn it. How far am I willing to debug? Okay. There's only one query. Which query would it be? It would be the jump size is 1, the k value is 1, and the number of things is 3. So it would be smaller than square root. So it would be this. So let me print the hash table. See what it looks like after all this processing. So, whoa, what? That doesn't seem right. The v value is 1. Oh no, it does seem right. Well, no, why am I... Oh, okay, something bad is happening. Okay, so my understanding is the m value is acting correctly, right? I'm updating the m value at index 0 to be 4. So this is the jump value. But the issue is the d value is also being set to 4 when it shouldn't. So, this should say bucket R. Okay. That should also say bucket R. Wow. There are 2 queries now. This one says jump up with 2 when there's 1, 2, 3, 4, there's 6 elements. So this one's smaller than the square root. This one is also this is jump up by 1. So it's also smaller than the square root, isn't it? So there's 2 buckets. There's 2 buckets. This one refers to I believe the first query, because it's a jump of 2, index of 1. And then this is the second query because it's a jump of 1. Yeah, it's k value first, and then, okay, so, what ended up happening was you had index 1, which gets multiplied by 3. Then this is index 3, which nothing changes. And then there's index 5, which is past the R value. So this stays as 1, but this goes by 3 because we're dividing by 3 so that we don't carry this multiplying by 3 across. Oh, wait, yeah, I think I did this wrong. Did I? Yes, I did this very wrong. I forgot exactly what this was about. It's about accumulation. Okay, this is actually completely wrong. I think it's, okay, let me just check. So this was created correctly, and I believe this would have done as well, because 2, this is index 0, jump by 2, this is 0 up to 2, in jump of 1. So index 0, 1, and 2 all have the multiply by 2, and then index 3 gets a divide by 2 because it's not affected by the query, so you should divide by 2. Okay, that's fine. This is completely wrong. It needs to be a, so maybe not completely wrong, but this part is wrong. The nums index is good. Breaking is fine. Cumulative product equals 1. Cumulative divisor also equals 1. Cumulative product can have the buckets multiply value, and then you multiply that guy on. And the cumulative divisor can have the bucket, oops, should I be modding here? Probably, right? Again, let me get rid of the mod. And then I'll just say for I in range n, nums at I mod equals self.mod. Just again, just so I don't have to worry about it for now. So now what I'm hoping for is that the cumulative product has been carried across. We're multiplying by 3, we're multiplying by 3, we're multiplying by 3. I don't need two values. I just need this, don't I? Cumulative product times by that, and cumulative product you then divide by bucket ID. Nums at nums index, multiply by that. Yes. I think I don't need that anymore. Let's try that. Damn it. Same thing over here. Okay. I should, I've already cheated this much. Let me see if there are any test cases. Come on, someone nice me. Let me test it with a bit more. I don't want to have to test myself. Nope. Yes! Yes! Thank you. Thank you, mate. Oh! Unbelievable. Nothing. The first two were correct. Those might be the... Oh, man. There's a lot of queries, but there's only... Whoa. There's only a few. There's only 2 buckets, isn't there? Alright, do I want to work through this properly? I think I do. Am I on the right track? Ooh. This one's smaller nums, but more queries and more buckets. Do I want to work through this, or am I... Okay, maybe we get lucky. So... Okay, here we go. 734. If I'm lucky, there's one particular bug, and this, after I fix it, everything will be right as rain. Okay, so the first thing is the first line is the nums. Second line is the queries. So what happens? We start with the first query, query 1, 0, 1, 3, 19. So the bucket we produce as a starting point of 0, the increases are by 3. 0, 1, 2, 3. Okay. Oops, that's the wrong thing. What? Why did I lose my eraser? So this should be the bucket, right? Because it's starting at 0, jumps of 3. So 0, 3, and 6. 0, 1, 2, 3. Yeah, the only valid indices are 0, 1, 2, and 3. Okay. We have to multiply by a value of 19 at index 0 up to index 1, which means we have to divide by 19 by the time we get to index 3. Fine. And that's the whole thing. 1, 1, 3, 0. So this should be a separate bucket because it's starting at a different spot. 1 with a jump 3, so it's going up to 4, and then maybe 7 as well. 1 up to 1. 3, 3. 1, 1, 3, 3. So it's the 1 has to multiply by 3, and then the 4 should divide by 3. So you're multiplying by 19, multiplying by 3, and dividing by 3 by the time we get to index 4. 2, 2 is the next guy. So 2, up to 4, jumps of 4, so 6, and that should be it because it's, yeah. So with a multiple of 16, so you're going to divide by 16. So that's the first 3 queries. 2 then 3 means it's going to be another bucket. How many buckets are there? Ooh, not enough. Right? Okay, so that's one issue. It's not really considering the buckets correctly. Unless it is. Hang on. No, it is. It's just, no, sorry. This bucket is the same. Sorry, I was wrong. So just to clarify, the very first bucket was a 0, 3 bucket. The second bucket was a 1, 3 bucket. And the third bucket was a 2, 4 bucket. Right? Starting at 2, jumping by 4. Same with this one. So you're going to multiply by 15. And then you're going to divide by 15 after that. So multiply by 15 and then divide by 15. Because for index 2 up to 3 and including 3, you should multiply by 15, and then after that you shouldn't divide by 15. You shouldn't multiply by 15. Then 2 to 1 means this, so it's a jump of 1, which means this is like the whole thing. 0, 1, 2, 3. 0, 1, 2, 3. I guess I have 4 as well. Let me just look at my size thing. N divided by k. N is 4 mod k plus 1. Wait, what? N divided by k. Is that right? 4. Oh wait, I did this one, didn't I? Sorry, I was looking at the wrong thing. This one's what we're looking at. Yeah. 4 divided by the k value is 4 plus 1 gives 5. Yeah, so this is what it will look like. So the characteristic tuple is the k value, which is 1, and then the starting map, the starting index, which is 0. 0, there we go. What are we saying? So it starts at index 2, you should multiply by 18. And then you should do that for index 2 and then not do it for index 3. Divide by 18. Done. Then 0, then 2. Oh, wait. No. I think we need another bucket, don't we? 0, 2 with a jump of 2 is 0, 2, and 4. The tuple is 0, 2, which is not the same as what we've had previously, right? Because 2, 4, yeah, definitely should be like that. Hang on. I've been doing it the wrong way around, haven't I? I've been doing the L value first. But in the code it's K value. That's fine, it's fine. 1, 0, 2, 0. That's this one. 2, 1. Where did 2, 1 come from? I'm not finished, but yeah, there's not enough buckets. Should I swap it around? It's K value first and then the starting. Okay, I'll swap it around. Hang on. I'm just talking about the tuples, the characteristic tuples. They're supposed to be written in the order of K first. So this one was K and then this one was K and then this one was K, which is 4, and then the starting, and this is K and starting, and this is K. And then starting, sorry. So these are all separate. So yeah, this mod this should give me this. Yeah, so it's starting at index 0, and we're multiplying by a value of 6 times 6. This one will also multiply by 6, so we're going to divide by 6 over here. That one's done. Then 0, 2, 3, 8. So hang on. It's a jump value of 3, starting value of 0, which has happened. To start at 0, you should multiply by 8. And then after index 2, which is here, you should divide by 8. Okay, 2, 3, 4, so it's 4 then 2, so it's this bucket. You start at index thing, you should multiply by, right, to this one, so it's a jump of 4 index, yeah, so it's this one, sorry, so this bucket. We're multiplying by 3 for index 2 and index 3, so this one we should multiply by 3, this one we should divide by 3. So that's one done, and then 2 with a 1 doesn't exist yet, it seems. So starting at index 1, increasing by a jump of 2, 5 should be, yeah. You are starting index thing, multiplying by 14. You do that for index 3 as well, so we don't write anything. Then at index 5, we're going to divide by 14. Yep. And finally, I should write the characteristic thing. It's a jump of 2 with a starting of 1. And finally, the last bucket is index 2. No, starting at index 1, jump of index 2. Which is this one still. Okay. Start at index 1, multiply by 20. But then you should end at index 2. So at index 3, we should divide by 20. So this is what my buckets should look like. So they're clearly not. There's my 2, 1 at the end, by the way. I've got a 280 in there, which comes from 14 times 20, so that looks good. Divided by 20, that looks good. Divided by 14, that looks good. Fantastic. So one bucket does look correct. 2, 0, multiply by 6, divide by 6. Fantastic. 1, 0, multiply by 18 at some point, divide by 18. Ooh, that one looks a little bit wrong. No, it doesn't. Sorry, I got confused. I thought that was part of it. Index 0, index 1, multiply by... Oh, no. Sorry, I am right, yeah. This one decided to multiply by 18 here, unless I wrote it wrong. Index 1, 0. Let me get rid of the ticks. So it should start at 0 and be a jump of 1. So it should be... Oh, no, sure. It would start at 2, wouldn't it? So it would be jumps of 1. This one. There it is. Yeah, interesting. Why did it write it here? 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Yeah, so it did that. But why did it put the 18? That's very strange. Why did it put the 18 before the 8? So that means, okay, so that indicates that my bucket R value failed. Because my R value is 2 minus 2. Yeah, if R is equal to L, I think this is wrong. I think this formula is just wrong. I miss some. Do I have to say L plus? L plus this? Because it's like this is how much distance there is from L. This is how many jumps there are. Maybe it's bucket L. And so this is how many. That didn't work. Okay, so that's kind of already wrong. But I'm curious as to why some of the buckets aren't even being shown when I print the hash table. Like I've got the 2-1 bucket, the 2-1 bucket, the 3-0 bucket. What was this one, wasn't it? Sorry. It's the 1-0. I've got the 1-0 bucket, the 2-0 bucket, and the 2-1 bucket. But where are the other ones? Ah, the square root must be 2. Ah, right. I forgot about that. I forgot about the brute force thing. So which ones won't get counted? Maybe if I just, I don't want to complicate the output actually. So which buckets won't actually exist because the jump value is bigger than the square root. So for any jump value bigger than, any jump value at least 2, I would say. Bigger than the square root. So yeah, bigger than 1.7. Oh no, bigger than 2. There's 4 elements, so bigger than 2. So yeah, this one won't be there. 1133. This one won't be there. Jump value of 4 won't be there. 4. This one will be there. This one will be there. This one won't be there. This one won't be there. This one will be there. Still got 3. Oh no, but they probably double up, don't they? Yes, 1 with a yeah. So this one's a duplicate. So 3 buckets. Okay, so that is working. So it's getting the buckets correctly. So it is just this. It's the my bucket R formula is wrong. I do back the bucket L though. That does seem to be working. So now it's just a matter of thinking. Okay, so I got rid of all my working. That was probably dumb of me. So just to remind ourselves, this is talking about trying to map the index, like index 0, index 2, index 4, for example, to the literal bucket indices like 0, 1, 2, 0, 1, 2, 1, 3, 5 in this context. Given the characteristic tuple 2, 1, 1, 3, and 5 should be mapped to 0, 1, and 2. So if I have a particular query, let's look at this one because this is the one that failed. Which one would this be? It would be this one, right? Okay. So the query was 2, 2, 1, 18, right? So we know the L value is 2, the R value is 2, the K value is 1, the V value is 18. Fine. This is the bucket that gets constructed, and the goal is to make 18 go times 18 go here and divide by 18 go here, right? So I know that by the query that it starts at index 2. It starts at index 2, which means by the L bucket formula, or bucket L formula, I'll use the same bucket L formula, we said, what did we say? It's L minus L mod K, whole thing divided by K. The reason it's that is because we're basically saying, what are we saying? Yeah, L mod K tells you the starting starting nums index, right? That's how we calculate each of these indices. It's L mod K. Minus the L, we get the distance between those two numbers, right? 0 to 2, 0 to 2, 1 to 3. We get that distance when we do this top part. Dividing by K tells us how many jumps it takes to get to 2. So in this case, it takes 2 jumps. In this case, it takes 1 jump. In this case, it takes 1 jump, because 1 to 3 with a jump of 2 gives me 1 jump. So this tells me how many jumps. Fair enough, right? How many jumps? Which is precisely what these indices are telling us. It's like, how many jumps does it take to get from the starting to this other element. It takes 1 jump to get from here to here. It takes 0 jumps to stay at here. It takes 2 jumps of size 2 to get from here to here. So that's good. Bucket R is a bit trickier in that the R index doesn't necessarily belong to these top indices 0, 2, 4, 0, 1, 2, 3, 4. Well, in this case it will, but it doesn't necessarily exist there. So we have to figure out, any one of these indices in the top will be of the form L mod K, where L mod K refers to the start, plus K times some M, where M is the number of times you did the jumping, right? So we have to find, and M basically is this index, right? The bottom indices, the bucket indices. So if we, for example, say, L mod K is 0 plus K, the K value is 2. If we plug in a jump of 2, we'll get 4, which is what this guy is. If we plug in, so this is kind of our formula to go from bucket index, if bucket index equals M, then nums index equals I, then this formula, I equals L mod K, L mod K plus Km is like our translation, which means in turn, I minus L mod K divided by K gives me M, which is where this comes from, L minus L mod, right? But we're looking for bucket R, which is not necessarily of this form, but we're looking for bucket R such that we're looking for M, we're looking for M such that M is strictly greater than R. No, we're looking for I, where I is strictly greater than R and I is of this form. Right? Because R refers to the rightmost index we're allowed to be, and I, in this case, is referring to the index that we should put the divider on, the divide thing on, which is after the R. So we're looking for L, so I is equal to L mod K plus Km should be greater than the R value in the query. So Km should be greater than R minus L mod K, and dividing by K, which is a positive value, M should be greater than R minus L mod K, whole thing divided by K. So therefore, I think M should equal the floor of this plus 1. So, because if we do ceiling, right, then if this is already an integer, then it will stay an integer and M will not be strictly greater than, it will equal it. So that's a problem. So we're going to floor it. We're going to floor it to make it integer. If it's already, and regardless, we'll add 1. And I think this should satisfy the situation. So I think this is my formula. So I was close. It wasn't the L value, it was the starting value, wasn't it? Right idea, but bad execution. I wonder if this will fix it. Oh. Okay. Well, all of that for that, so that's funny. What if I'm surprised. I thought this plus 1 would fix all that for me. Should put spaces between here and here. R minus L mod K. L mod K, whole thing over K, and then add 1. What if I just say like plus 2 or something? Just like extra buffer space. I'm really surprised that it indexed. No way. It's a bit cheap, but no, but the math should clean up nice. It shouldn't do it like that. Is that 18 there? Was it case 4, right? So now, yeah, so now the the multiplying number is being put correctly, 18, and then the dividing number is putting afterwards at the divide by 18 spot. Ah, I don't really like this. I'm wondering what's happening. I guess for example, if the yeah, I think that makes sense. If the R value sort of spills past okay, I think instead of saying +5, I think what you should say is the L value we're pretty confident exists, but the R value, the bucket R value might spill past because if the input R value in the query is like really big for no reason, because I don't think is the R value restricted? Oh, they do, so it's less than N. Yeah, but the next one over might really spill past the maybe you should say plus like K or something. No, surely not. I really feel like +1 should work. All right, we'll say +5, and then we'll just say if, as a deterrent, if bucket at R is greater than or equal to the length of bucket, then just, I guess, continue. Because we're not really looking, like, as soon as we hit that index, like when we go past, we break out anyway, so. Do I back it? Do I back it? I feel like I do, almost. I feel like I followed the hints quite well, and I think the time complexity is good. I'm just a little bit concerned about, like, random stuff. Ooh, memory. That's not the same as, interesting. So my hash table got too big, is that right? Just to clarify? Like, because, yeah, because I didn't even print anything. That's a real shame, that. So shorten up the... Ah, unless it's because I wasn't modding. Maybe because the modding was a problem? If I mod, does that help? I try to cheat my way out of it, and like maybe the numbers themselves are getting too big. Could happen. Okay, try again. Ah, okay. Well, that's why I didn't want to mod, because I thought something would happen with the math. Now I failed an actual answer. This is legal, right? If you're going to multiply by something in a particular mod, like you're allowed to mod the thing you're multiplying by, right? Damn. Just to clarify, if I don't do all that modding, get rid of that, I think. If I don't do all that modding, does it end up correct? Yeah, it does. Oh, my heart bleeds. Okay, hang on. Surely there's a way we can do a bit of a compromise. What if I do this? So silly. Oh, maybe? So wait, so this is a problem? How? Probably because of division. Please work. Please? No. Ah, what? 603? Wasn't that the same as this one? Nope. This was 602, was it? So annoying. Wow, leak code. Really did me like that. Okay, I'll keep the last 4 and get rid of the first 4. Wrong answer, huh? That's a real shame. My poor streak. 801. All right, I'll do another like 10 minutes. If it's not happening, it's not happening. We came close, and the idea is cool. I think I can apply this idea nicely, even if like this idea of like I want to work with a sequence as if it's contiguous, but it's not actually contiguous, so I have to map it to like a contiguous thing. It's nice, you know. It's a cool idea, even if I can't quite execute 100%. It's not bad. Can I check? First things first. Again, if I get rid of this mod, does it give me the correct answer? So one of them will memory. One of them might give me a memory error. It's probably this one. Put this. I'll push this to the end. So let me just double check. So submissions. Which one was the memory limit? 922. Oh, it's this one. And the 1, 2, 3, 4, 5 was the one that's giving me grief now. Right? Oh, not that one. Sorry. 1, 2, 3. Yeah. So this one should. So this one should pass. I think this one should fail. Everything else hopefully will. Oh, I might get a memory limit because I got rid of the mod thing, didn't I? Oh, it's still wrong. Okay. That's more interesting. I thought, okay. Is modding, because no, surely modding again won't do anything. Like in the sense that like this extra modding, if it's already below the mod value, then it's not going to affect it at all. So it's not going to do anything terrible. I was thinking maybe like I wonder if I just have I'm assuming like the fact that it's worked so far with all these different cases and it's just one particular one, it makes me just think that like somehow the numbers are being a bit funny. When you mod. Oh, you can't see. Oh. 1, 2, 3. Oh, that's the. Oh, okay. Fair enough. Like, since you're gonna divide by this number, I feel like modding it kind of is a bit dodgy, you know? Division is always a pain in the ass. All right, everything's breaking. Very good. Case 2 also broke. Oh no, that's the one. What's this one? This one was passing, wasn't it? How can you pass this? Not pass this? 5 more minutes. Unbelievable. I swear to God, if I gotta use like Fermat's little theorem or something, I'm gonna be really annoyed. I doubt it. Also, this wasn't divide and conquer, was it? Unless divide and conquer was literally like square root of n. I guess it's kind of. I guess it is divide and conquer technically. It's very misleading though. Simply brute force it. Yeah, I'm really not sure. What if I only look at test case 2 and I get rid of all the mods? Will the memory still be a problem, or? Because in my mind, I can't imagine what else, in terms of like pure math, pure mathematical ideas, without thinking of memory constraints and modding. All I can think is that it's like, I can only imagine is correct, but I'm not sure. Like, I'm not sure where it would go wrong, because I just feel like, oh, my bad. Submissions, not solutions. And then use test case, get rid of the first line. All right, let me just, if this at least can tell me if I get like the correct answer, basically, that'd be really, I'd really appreciate it. See, I'm not really solving anymore. I'm just like guessing. Unless it's this. Maybe, I mean, this is the only other dodgy part of my code, right? A difference array. Maybe a difference array isn't this. I'm pretty sure difference arrays are about like that. Like, the thing about difference arrays is their biggest idea is about that cumulative idea. Like, you know, if you're going to do an effect on a particular range of numbers, you only write that effect at the very start of that range, and then write the reversal effect past the range, like we've been doing with the m and d values. I think that's what difference arrays are all about. I could be wrong, but I don't think, I feel like it's a mislead. I feel like I remember it being like a bit of a weird name because it doesn't quite do what it sounds like it does or something. I could be wrong, but yeah. Well, you know, we came close. I do think it's something to do with, like, I just, from memory about modular arithmetic, like, dividing in the world of mods is like really dodgy. You're better off like using like multiplying by inverses. The issue is, I remember trying to do that in a previous LeetCode question using like the whole Euler's theorem or whatever. Unless 10 to the 9 is prime. Wait, hang on. Is 10 to the 9 plus 7 a prime number? Ooh, okay. Okay. Late call. I won't get rid of this actually. Late idea. Division is a bad idea in modular arithmetic. There's like a lot of extra rules and stuff. But what does Fermat's little theorem say? It says a to the p minus 1 mod is congruent to 1 mod p, where p is prime. Is that correct? Fermat's little theorem. Yes. Okay. I backed Gemini because I already thought that anyway. So yes, a to the p is congruent to 1 mod p. So the inverse of a is equal to a to the p minus 1. No, that's not true. Wait, what? The inverse of a, so this is the same thing as saying a times a to the p minus 2 is congruent to 1 mod p. So that means that this guy, when you multiply this guy by this guy, you get 1 in the world of mod p. Which means this dude over here is the inverse, isn't it? If that's the inverse, then if I can find this value, what, a to the 1,000,000,005. Oh, but there's like tricks and stuff. Is this dumb? Is this a bad idea? It's probably a bad idea, right? Oh, I thought I had a thing. I forgot a billion and seven was prime. As in, I say I forgot. I didn't know that actually. So therefore, instead of like having to do any division, you do more multiplication, but you're multiplying by an inverse. So it's essentially division in the world of mod P. So it should be accurate. So oops, looking good, mate. The D value won't hold values that you're actually dividing by. It's going to hold the product of inverses multiplied together. But how do I feel like I've seen this trick before where like a to the p minus 2 is like the inverse. I feel like I've read solutions in LeetCode before where they do this trick. But I don't remember how they do it. Now I'm sad because I really feel like I've seen this before. This be used in problems. But I can't remember how they used it exactly. Because a to the p minus 2 sounds kind of massive. Where p is a billion and 7. So there must be a way to... I don't remember my modular arithmetic enough. Or my Fermat's theorem. How do you get such big powers? Ah, wait. A billion and 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's got factors in it. That doesn't help me. Why does that matter? I said a billion and 5 is p minus 2, right? Alright, I'm a cheat. I tried my best. Wasn't good enough. Came close, but no cigar. Is there any Euclidean algo? That could be GCD stuff. That could be it. Is it does it use it at all, or what the heck? Inverse? That's a nice dog. What? Square roots and stuff? Hmm. So wait, what does he use? So what's the code that he uses to define which computes in the inverse of I, which is equal to mod inverse of I? Okay. So did you make a function called that? Oh, sorry. I was looking at all the outer scopes. I was like, where is this thing? Okay. Long, B equals mod. Okay. I'm assuming that's that's outside. So given an A, long x naught equals 1 and 0. Okay. While B is greater than 0, auto QR is equal to divide A and B. Euclidean algorithm. This is like how you find GCDs, isn't it? What does that mean? Exchange. Okay, yeah, you're running the Euclidean algorithm. Okay, I don't know what that does exactly, but I imagine it's, yeah, I know what the Euclidean algorithm is. Okay, while b is greater than 0, yeah, because you terminate when the... Wait. Yeah, you terminate when... Do you terminate when... Okay. It's like q equals ab plus r, and then you make... Oh, man. God, wow, okay. Wow. Return, if x naught is less than 0, then return x naught plus mod. Else return x naught. Exchange x1 with x naught minus q times x1. Alright, this is a bit beyond me, if I'm being honest. I think my issue is the fact that, yeah, I'm dividing instead of using the inverses, but... Is the editorial free? Oh, wow, thanks, man. All values set to 1. Also inverse. Fermat's little theorem. Each query... Oh, man. Okay, so they also do the inverse trick. Power, long x, long y. Wait, are they actually just plugging in? Surely not. Wait, is exponential... Wait, yeah, there is a thing where when you take a... There's an inbuilt function that, like, when you take a big power, it, like, figures it out for you, right? It's like log time exponential modular something or other. Wait, does the Python pow function do fast exponentiation given a power? Everybody, this might be a play. Why is my internet not doing good? Is this a good idea? Okay. Wait. If you pass in... Wait, what? Why is my computer not doing stuff nicely? What? I thought POW could also take in a mod, was my memory. With mod? Oh my god. With mod? You are so mean to me. Why is... Okay. I think this is real. Oh, I keep clicking that. Okay. Okay, one more time. So def get inverse given a particular thing. Okay. Boys and girls, we are going to literally turn given a, given self.mod minus 2, and given self.mod. And we're going to pray that works. And then whenever we try to do this guy, we're just going to multiply And then we're gonna multiply the amount you should. We're gonna multiply the inverses onto the accumulated product. That tells you how much you should reduce by. Please work. For the love of all that's holy. Okay, maybe? I did get rid of a lot of test cases. Hang on. Is this everything? I don't actually know anymore. My submissions. Oh my god. Get rid of the first one. Is this 9299 thing? It is there, isn't there? Please. Let there be light. Please. Oh, you're so mean. Memory limit, it's not even speed. But I modded like everywhere, dude. Oh, no. Just to clarify, do they literally do 1 billion and 5, like for the mod thing? I think this is the fast exponentiation thing. There's no way that the actual hash table is crazy, right? Maybe I'm not modding everywhere. Oh no, I mod here at the end. I keep the numbers smallish, kind of. What is the acceptance rate? Well, I tanked it. Huh. Oh, I said I'd finish 10 minutes ago. Oh, you're joking. How is it still not good? I did the thing and everything. Pal? Where do you call the pal function? In your thing, that is. Yeah, they literally do. Oh. I guess you don't really need 2 spots. You could do it in 1. Because if everything is multiplication, it's different with division, because with division it gets weird. But with multiplication, yeah, you don't need to make it 2D. You could have it as 1D. Because you're literally multiplying and then multiplying again, so you might as well just keep them the same. Maybe you know what, that could, if it is a memory problem, maybe that's the reason. Hang on. So I said originally it's going to be 2, it's going to be 1 1. What if instead we just say 1, and then yeah, bucket L, bucket R, this is the same. Get the bucket. This one should be this one multiplied. I am basically cheating, but I'm so close. Like, and then bucket R should equal bucket R times the inverse mod, and with the mod thing. Oh, I've no more space left. I basically halved my space, right? kind of. Again, I'm not sure if the dictionary is actually the thing that's... Oh, yeah. Do that, and also don't do that. Because this information carries both the multiplication and the division information, or the inverse information. I can't tell if it's working Wait, will this work? Or 6.5 seconds is actually quite insane for one of these problems. And it's like the middle of the... Okay, I did cheat, but like I had the ideas. I did have to use the hints, but I had the ideas, and this is a cool trick. This is a cool trick. Not this is annoying. This is genuinely like the most piss taking thing. This was fun. This was an interesting idea. Mapping the original indices from nums to like these little buckets indices. That was cool. You know, a little bit of math involved. That was nice. This, I can't believe you have to. That's such a random thing to have to remember. If that's like legitimately how you would be expected to deal with this, is like, oh, don't divide, use inverses. That's so mean. Luckily, that it's inbuilt. I happen to remember that this is inbuilt, and I basically what you should call it? I basically confirmed it, but unbelievable. And you got some people who did in like 3 lines. Oh, they sorted it. That might be smart, actually. Residue class, goddamn. Okay, so you can make answer equal to 0. I was worried that if you XOR'd 0, something bad would happen. That's why I did it the way I did it, which is like I started with the first value and just went forward from there. But you can start at 0, yeah. Okay, fair enough. Is XORing with 0 identity? If you XOR anything with 0, do you get the same thing back? I mean, that's what this is saying, right? 1 XOR 0 is 1, 0 XOR 0 is 0. Oh, okay, yeah, then yeah, it does. Ah, wow. Does this guy also do the inverse stuff? Yep. Crazy. Oh, it's so annoying that you have to know that. Anyway, had to persevere, but we got there. Alright, I'm hungry.